Hi, this is Team TMJ, and let us ask you a question. Have you heard about smart contracts before? Well, many blockchain-based ecosystems rely on them because their transaction records are immutable, verifiable, and securely distributed across a network. Ethereum is a decentralized blockchain platform that establishes a peer-to-peer network that securely executes and verifies those smart contracts. However, what if you need to do scalable testing and profiling on them? Because of the recent increase in the use of those contracts, it has become a challenging task due to the main bottleneck of the Ethereum client, storage operation. That is why Kim Yeonso, our research advisor, and Jong Sung-woo, guided by Professor Berd, Burgstaller, and other colleagues, came together to make an off-the-chain execution environment for scalable testing and profiling of smart contracts. In other words, they made a substate replayer, which is a smaller version of the Ethereum client that reduces the space required to replay transactions. Furthermore, the replayer could be used to do scalable testing and analyze for metric use cases, fuzzer use cases, and hard fork assessment too. The replayer is able to run 4.54 times faster on a single thread and 50.03 times faster on 44 cores. However, it can still be improved in terms of performance. For that reason, our team had the task to find the main bottleneck of the replayer so that it could be optimized.
We wanted to know whether storage operations are still the main bottleneck or what other instructions are. The method we used was software instrumentation to add profiling code. We worked on two branches of the record replay repository for this experiment: macrotime and microtime branch. Macrotime is macro instrumentation to profile software components, for example, RLP, KVDB, check, get. Microtime is micro instrumentation to profile EVM instructions, for example, push 1, sstore, sload. Lines of codes were added to these two branches based on the diff output between the research directory of the GoEthereum repository and the record replay repository. After this, experiments were conducted on a small scale from 1 million to 1.1 million blocks, and at a larger scale from 0 to 4 million blocks using different amounts of CPU cores. Workers 1, single thread, Workers 4 or the replayer default, and Workers 44 or 44 cores.
We then visualize the output of the experiment. From the graph, we can conclude that RLP, which is the main encoding method used to serialize objects in Ethereum, is the main bottleneck of the replayer for micro-time branch. For micro-time branch, there are no particular instructions that consume the most time when running the replayer compared to the original get where sload and store were. The replayer we are working on is based on get 1.10.15. The newer get version, 1.10.17, claimed that a lot of optimization for RLP encoding and package try were added. Roughly 20 to 30% improvement, so we can conclude that if we were to optimize RLP on the replayer, then it would likely increase their performance as well. Thank you for watching.